So our next talk will be by Daniel Lever, and he has some wishes for the VeriPB proof system. I'm very excited.
Thank you, Andy. I will have sort of a provocative statement, and that will sort of answer Albert, I think, statement. So let's just start. Sat4j is 20 years old this year, so which means that it's older than one of my kids. So I've been working on this for a long time. So you have SAT, MaxSat, and PBO solvers, and actually most of the development was done more than almost 15 years ago. Even if, in less than 10 years ago, so Emmanuel Lonca did his PhD on multi-objective optimization on it, and Romain Wallon studied proof system and implement some of them in Sat4j in 2020. But so mainly, this is a software which is maintained for more than a decade, right? But so what makes Sat4j a bit different from other systems is that you have two proof systems. You have a resolution-based proof system. And actually, when we designed Sat4j PB, we only wanted to work on cutting planes proof system, but it was too slow. So that's the reason why we also implemented resolution-based. And by default, when we use it, we use it resolution-based. Just to give you an idea of what is proof logging currently in Sat4j. So in 2013, I implemented the DRUP and SAT format. So I have a question for you. Do you know when was the first SAT competition when we got a certified UNSAT track?
Wasn't it 2013 or 14? Something like this.
Okay, it was 2005.
Okay. Yeah, right, yeah.
In 2005, that was the first certified UNSAT track. There was only one solver participating, ZChaf, and it was with a resolution proof system. And this is where I learned what was the limit of the file system on Linux, because the proof was so big, I had to remove the limit on the file system to allow to generate the proof. So that was resolution. Then we got RUP, and a bit later, but it was still not a good thing. And then in 2017, we got DRUP, RUP with deletion. And this is exactly when we got UNSAT certificate mainstream and mandatory in the SAT competition. And this was really important, and this is why I got DRUP in Sat4j. And to give you a small thing is, I forgot the D in the proof, and so almost none of my proof could be checked in the 2013 competition. So I had just to add one line to add the D in the proof, and then everything was fine. So just to give you an idea, so it took 8 years to go from we want to have the certified track to have a solution that works, and this is important, I think, for this talk. So 3 years ago, Anthony Blum was my PhD student on work in implementing VeriPB with Romain Wallon. So mainly the point is in Sat4j you have events when you do whatever things, and so a proof is just a way to log the events. And that was VeriPB1. And then this year, maybe some of you know that IDRUP format. I will give you will show you an example. This is something that Amin, Catalin, and others have been working on. And so, because we had the PB competition, well, I said, okay, I'm going to implement VeriPB2 for optimal on UNSAT. So that was what my plan for this year. So what there is, I think, one difference between UNSAT, so VeriPB1 or DRUP, and the other logins. So if you do UNSAT, you just have to worry about one search space. Okay, you start the search, you log everything, and at the end you are UNSAT. So if you do incremental SAT, or if you do at least if you do it, whether core-guided or linear search, you will have many calls to the SAT solver. And so it means it makes a bit, it's a small difference in the way you are going to implement it. But mainly for Sat4j, it's not a big deal. You just have events, and actually you will just log those events. So this is the complete proof login for DRUP in Sat4j. Okay, so I just the format is a bit strange, but it just to make it clear. And you see this delete. This is the thing I forgot in 2013, and I just added those lines, and my proof were correct. So it means DRUP is very easy to integrate in whatever stat solver. Okay. Now, what about VeriPB1? So mainly, it's the same thing. So it doesn't really matter what this means. We have shown with Mark and so on what kind of things you have, but mainly you are weakening, you are doing things with reason and so on. You are just logging things. So same thing. It was not really a big deal, but just mention that those are uncrafted examples. There was no competition. We had our favorite benchmarks, and we could check it worked. Then this year, I worked with Armin and with Matthias and with mainly Iris Parika. She did a master thesis on adding first testing, API first testing in Sat4j. And so what we did is that we used that the fact that she was working on API fuzzing to implement incremental IDRUP in Sat4j. And what you do typically in incremental DRUP is that you are going to log all the constraints you add in the solver, all the queries you are going to do, and you can get the answer. So it can be sat and you get a model. It can be unsat and you will get a set of assumptions. And there is a format for that, and there is a checker for that. And here is the example that you can find in a presentation of Catalin. So on the left, you have the ICNF. So the ICNF, you have the I line. This is for inserting constraints. You see that you have a query. So you query under assumption. So you query with assuming 1 and 2. So it means that you are unsat, and you get sort of an unsat core in terms of literals, and you get 1, 2 is an unsat core. And then you can add a new constraint, or here 2 new constraints, a -1, 2, 1, -2. And you query with no assumptions, you will get a satisfiable answer. Then you will get a model. If you add a new constraint and you make a query, you come unsat. So this is the interaction you get with the solver, and the proof is just the ICNF file plus additional things. So the constraints you learn. So you have the learning here constraints, learn constraints. And what do you have? Yes, mainly those are only the learned constraints that you add. Okay. So what was it difficult to add? Well, mainly it's not a big deal, right? It's just that there is something funny in Sat4j. So in 2004, the first version of Sat4j submitted to the 2004 competition was called mini learning. Why? Because you could derive a constraint, a clause, but you may not want to add it to the solver. You would use it for conflict analysis, but you will not watch it. So you will not see any unit propagation, you will not see any conflict. But since it was necessary to propagate a value, you would keep the constraints as long as you are in that part of the search, and then you will forget it. So that was called mini learning. And actually, because Iris was working on API first testing, she was checking all the possible combination, and just she checked the proof on mini learning, and it didn't work. Why? Because you need to log that you learn that constraint, even if you are not watching it. Okay, so this is kind of a very small thing, but from a proof perspective, you need to log it. And so the only change I had to do in Sat4j was to create a new event called ignore when I ignore something, when I do not add, when I do not watch a learn constraint, I just log that I ignore it, and that's fine. Then, so one thing is, I haven't used mainly mini learning since 2004. So without API fuzzing, there was no chance I could find this bug. So API fuzzing was very important to find this issue. And then I decided to implement VeriPB2. So this is what Mark just showed for linear search. I mean, it shouldn't be a big deal since we already had the VeriPB1 for UNSAT proof, okay? And so because IDRUP was already managing multiple calls to SAT solver, there was no problem. I took all the test case for VeriPB repository, and I was able to reproduce them using Sat4j, so I was fine, very happy. Well, what I didn't really pay attention at, there was quite a few changes compared to VeriPB1, so I mean, I had to try to figure out. And then so I have two things, and maybe Andy will be able to answer me. I hope you can see my slide. So I received that kind of email from Olivier during the PB evaluation. What's going on, Daniel? What are you writing output derivable implicit? Why you should use output none? Well, maybe because I didn't really understand what I should put in output. And this is actually the whole code for the output. So, okay, so display conclusion, I'm not sure if you can see it, but so typically here, I'm almost always writing output derivable implicit. And then I put the conclusion depending of the different cases, whether if it's unsat, whether you have a bound or not, then you will say optimum found, or you would say satisfiable. And just if none of those cases apply, I will say output none. So I reread the documentation yesterday of VeriPB. So I'm not sure if I'm correct or not, but you know, this is that kind of things when I had to output it. I mean, there was no issue with this in VeriPB1. I mean, it was complicated for me to know what was really the thing to put. So maybe I've made a mistake, I don't know. And well, I mean, we can discuss about that. So it's a bit complicated to output, even if you believe that you do the things right, maybe you can have issues with that. But then there is a more problematic issue. And we are coming to see the point that Albert mentioned. So we mainly use VeriPB on crafted benchmarks, okay? Because we were interested in proof systems and so on. And then we have a PB evaluation, a computation. And then there is a difference between crafted and toy benchmarks and the computation benchmarks. So mainly you can have unique clauses in the computation benchmarks. You can have constraints that could be represented in clauses or cadenity constraints, not just PB constraints. And actually, during the training phase, many of the Sat4j cutting planes proof were incorrect because of that. Because in Sat4j, if you have unit clauses, then I simplify them right away when I read it. If I have some, I try to represent constraints as in the best form. So if I have, for instance, 3x1 for 3x2 xn greater than 7, I will just divide by 3 and I will have a cadenity constraint and so on. But this is not part of the search. This is when I read the constraint, right? And so it means that, well, I was not able to properly output the proof for Sat4j cutting planes. And what was very painful for me was that the resolution proof was perfectly correct because everything was RUP, okay? So it means I have two solvers. The only difference between the two solvers is a proof system. So I do the same modification on unit clauses and represent all the things for the two solvers. And in one case, no problem, it works. And the other case, it doesn't work. And this is exactly what Albert pointed out, because you have to give all the precise changes you did. And if you do not do it, your certificate won't work. And this is not what we got in SAT with DRUP. With DRUP, it doesn't really matter how you end up learning that constraint. You just want to check its rep. And that allows close minimization, that allows to do a lot of different things that are sounds, because at the end of the day, this is something that you can derive. And this makes a big difference between VeriPB, for instance, and the DRUP format. And so the thing is,
if you allow me, Daniel,
yes,
it's not a difference. It's not a difference between DRUP and VeriPB. It's a difference between clauses and other things than clauses. Those things that, you know, the only reason you can do this automatically is that clauses are so simple. Is that you cannot get DRUP for pseudo-Boolean constraints in that way. It just doesn't work. It's not possible.
Well, I don't know. I mean, I'm not. If you could, I think if we could just, you know, find a way to sell as far as the constraint I have is implied by my constraints, I'm happy with that. So I mean, the problem is exactly
but in such a proof logging system, you could solve UNSAT immediately, right? Because the empty clause is always implied. So clearly, implication is too strong.
No, but not I mean, we do it with unit propagation for SAT, so it would be something similar. You know, because here the problem is really that we require VeriPB ask all the steps. So this is maybe something you want to do if you really want to check the reasoning part of the solver. But this is really not what's going on for SAT. For SAT, you just want to check that what you derive is sound and correct, and you do not really care how you end up there. And I think this is at least, I mean, this is from a solver designer point of view. If I want to implement your proof system, it makes me it's a bit of a pain to try to implement VeriPB2, while for the other proof system, it's very easy. And especially, this is my point. VeriPB2 is friendly to resolution proof system and unfriendly with cutting planes. Because I have two solvers, my proofs are accepted if I do resolution, and if I work with cutting planes, no. And
that is because the proof system is stronger. I mean, we would love to give you that. It's not possible. That's because you have an exponentially more powerful proof system. So it's not that, you know, resolution is easy. Cutting planes is more complex.
No, I agree. But the point I want to make is VeriPB is like the resolution proof system we had back in 2005. When this is exactly my point. I think we need an intermediate representation of the constraints that for which we have sort of a more complicated way to check, but that are equivalent to rep constraints. We need to find a way to avoid having to give all intermediate steps to arrive to a given constraint.
And you're now convincing me that I should write this up and submit this as a paper. We thought about this. Maybe I should write it up then. You know, it's not possible. It would be a dream scenario. If it were possible, if we knew how to do it, we would have done it. But like we've thought about it a lot. It's like it's really, it's not that we're lazy. It's like
so then
resolution is so easy. That resolution clauses are simple.
Well, you know, it took 8 years before finding a way to properly do this, you know, for SAT. So and if it's impossible, then I think it should be, yes, this paper should be written, and maybe someone will find a way. But I mean, again, it took long to make DRUP. So the point is, I don't know, but actually, so okay, let me continue. So currently, I cannot put VeriPB2 in Sat4j because the proof are incorrect for in real life. Okay, for the for cutting planes. So it's just on its specific branch, and it's a bit of a pain. And so how to fix this? So you could tell me, well, you just have to do, your work in Sat4j and just create as many events as you have all those each time you do the unit propagation, when you read, because for any type of constraints, I have some simplification. And yeah, so even if I do not have to touch the 40,000 line of code, I mean, there are quite a few line of code that I would like to change and that may break the code that I've been living quietly for a long years. And so I'm not really willing to, so there are things you can do for unit propagation, you can do, but for the simplification, it's not more complicated. And if you do API first testing, it can also help. And but I think, so if it's not possible, then it would be a good paper to show that it's not possible. But I mean, VeriPB should be, well, shouldn't be so picky about how you derive things. It should allow some equivalent transformation, and especially all those, if you have a PB constraint that is equivalent to a kinetic constraint, it should be okay. And it shouldn't be a problem to replace one by the other. And to provide a proof for that, it should be okay, because it works if you do resolution. Again, it doesn't work if you do cutting planes. So that was my wishes, and I'm very happy, Jakob, that you could hear directly. It was my provocative stuff.
Okay, so thank you so far. And I guess we can continue the discussion now, or are there further questions?
So I somehow support the view of Daniel, and I agree with Jakob that everything is much more difficult with PV constraints. Yeah, but if I try to look it from a very abstract point of view, if I see a community that somehow is developing solvers, and of course we want to make sure that solvers are correct, okay? And for this reason we do proof logging. Yeah, but then if I start seeing that it is almost as difficult to implement the technique than to implement the proof logging of that technique, then there's something we're doing wrong. This is what I would say. Yeah, from a very abstract point of view, if I do not know the details, this is what I would say. That doesn't go anywhere, because you cannot spend the same amount of time developing a technique as developing the proof logging version of that technique. That doesn't scale up. That's my feeling. And I'm not saying I would do it better. I don't know how to do it, but this is the risk that we're having here. Yeah, as Daniel pointed out, between 2003 and 2011, when DRUP was produced, people just would not incorporate proof logging into their SAT solvers because it was a pain. It was a real pain, and we're having, facing a similar situation here. So I don't know if it makes sense to. So when Jakob says, "Well, this is not possible," I guess that he says that this is not possible because he doesn't want the verifier to solve NP-hard problems.
Yeah,
I fully agree. But NP-hard problems are fake. It depends on the concrete impact. It depends on the size. Depends on the particular application. So of course, worst case, it's going to be exponential. But I don't know. Maybe you can add some, more expressive primitive in the proof format that, in the worst case might be exponential. But, most of the cases, they will just go through and be able to fix this. And, it was just a very, I can't talk about this because I don't work in proof logging. I will not work in proof logging. But that's my feeling from a developer point of view. That's what I would ask you.
Well, firstly, I think we would need to see what the hard. I don't agree. If you have a cardinality constraint that is equivalent to pseudo-Boolean constraint, that's a one-line proof. You just need to, divide, right?
Yeah.
So it's a triviality, and so the only thing the proof logging, like the code, is doing this, and literally what is already there in the code, you just have to write it to the proof log file also. So we're not like. It's not like the proof format is asking you to invent new stuff that wasn't there. You just have to, since we have pseudo-Boolean constraints, since they are so much more powerful, unfortunately, you cannot just, I agree that it's wonderful in SAT that you could just say, hey, I learned this clause, you figure out the details. Okay, that is just not possible to do in pseudo-Boolean solving because we're using stronger. Basically, you can say like, okay, so if you want to zoom out and see why is SAT proof logging working, and what is the generalization of this to pseudo-Boolean solving? Well, the strongest possible RUP you could imagine, in some sense, would be something like. So let me see if I can say this in the right way. I mean, sort of what SAT is doing, it's saying for free that something that follows from the LP relaxation, I can verify that because I can run an LP solver. That's pretty much why RUP works. But if you do pseudo-Boolean conflict analysis, that will very much not be you'll get something that is potentially much stronger than what the LP relaxation implies. So you're doing tons of, a SAT, what you could get with RUP is basically what the LP relaxation tells you. But if you now have the same constraints, and the only reason you can derive this other thing is that you're doing tons of sophisticated cuts all over the place, you're tighten the polytope, and then finally you can see this thing. It's unreasonable to ask the proof checker to guess all these cuts that you did. We just won't be able to do that. But since your solver did apply these cuts, the only thing we're asking you, well, you did these cuts, could you please tell us what these cuts are, and then we'll check them for you. But we can't, if you did 100 cuts and got this amazing constraint, I'm sorry, I can't guess your sequence of 100 cuts. You have to tell me. Just tell me, and I promise I will check it's correct.
Yeah, I mean,
I understand this, but for example, let's take an example. Yeah. So Jordi was presenting yesterday this max TVCL thing. Okay. So if I have a look at the techniques he's adding to max TVCL, there's nothing really substantially new. The ideas he's using have been around for 15 years, maybe. Because you're saying it's essentially something like core guided discovery. When you do the look ahead, it's very similar to this. All this thing about deriving the clause, this is SMT, that has been done for a lot of time. Okay, so you implemented it and it's super nice and it does work very well. I'm not talking about this unlocking because I still don't understand it. Yeah? But taking unlocking away, everything that he did has been around for the last 10, 15 years. But now DRUP is having, I wouldn't say a hard time, but it's not trivial for DRUP to do the proof logging of this. And to me, this is surprising.
Actually, I mean, since I'm also working on the implementation, I think it's more complicated to implement the proof logging than to implement the technique itself. So sometimes.
So I'm not saying that I would do it wrong, but I'm saying is, we have to be careful what this project is going, because is it really somehow slowing down the progress of solvers because proof logging will be so difficult that you're going to spend 1 month implementing the technique and 3 months implementing the proof logging? I don't know. And I'm being provocative, Diego. I know that you've done this a lot. Yeah, but I think that
But I think maybe a clue here could be to think about some meta rules. I mean, for instance, in MaxCDCL, we're using cutting point derivation, but in a very specific way. Like I'm trying to join this course. And maybe you can make a rule out of this, a local rule for max-ACL, and VeriPB could support things like this, you know? So some kind of local rules that even if they are based on the full potential of VeriPB for very specific cases, it will really help, you know, in a much more compact way. Somehow.
It's like, you know, the guys that are doing this proof logging, you should go to Jacob and say, this is my wish list. If I had this in, you know, in the VeriPB format, you know, it would make my life much easier. And then, you know, it could be the case that different projects come with an intersection of wishes. And then, I don't know, that might indicate that would be something to try to incorporate into VeriPB, and hopefully most of the cases be efficient enough so that is checkable.
Just to say, if I'm sorry if I'm interrupting someone in the room. I can't see that, but so firstly, I think we want to push back. Like we want this to be useful. So just to be clear, it's very, very important that I mean, if you know, if you try to implement a Sat4j proof logging and it didn't work, that's an extremely serious concern. Just to be clear, so we want this to be useful. And I think, Albert, you're also making a valid point that, you know, it's definitely the case, and it has been a very serious concern from the very start that, well, if this gets too complicated, nobody's going to do it. And I do agree that indeed, MaxSat proof logging, it is working, but I think Dieter is the one person in the room to ask about it. Like it's a lot of work, and also we had a paper on solution improving search with the most sophisticated techniques, and that was ridiculously complicated. So I would say maybe a few things to this. The first thing I would say that, well, literal unlocking, for instance, it kind of is fairly complicated, I would argue, when Jordi is doing the example. So maybe it's not completely unreasonable that, you know, constructing the proof, like if I cannot understand his example without thinking very, very carefully, then maybe the proof logging code will, for the same reason, be somewhat complicated. The second thing, and Dieter can perhaps elaborate on this, is that in practice, whenever we have done a proof logging paper, I think what you end up doing is you have a whole library of, you know, proof log this, proof log that, and then the actual proof logging code will be a lot of sort of library calls for techniques that, oh, now we need to do this thing, and you won't like write it out. You will have some kind of procedure that takes parameters and generates the thing for you. And maybe like something to think about, and maybe this would actually, maybe we should think very seriously about this and maybe do a paper about it. Like, could you build a library on top of VeriPB and think about, like, here are things that you typically want to do, like the kind of things, like the kind of thing Daniel would like to do. Okay, here is a I don't know, a cardinality constraint. I want to argue that it follows from this thing, and maybe a few hints on how did you figure this out, and then just, you know, a piece of code, that a library that writes out the magic 3 VeriPB lines that you want. Because that sort of, again, Dieter will correct me, but I think that most of the proof logging code will have this structure that you have a library where you really work on like very specific proof logging components, and then you put them together somehow. The third thing I want to say, and final, I'll try to be quite soon, is that I think part of the problem is that proof logging is coming after the fact. And if you talk to the constraint programming people, like Kieran McCreesh, Matthew McIlree, these people in Glasgow, who are now, it's a little bit different. They're building a CP solver with proof logging from the start. What they are reporting is that proof logging actually speeds up code development significantly. And the reason for this is, for free, you get highly sophisticated debugging. Sort of, you get unit testing for free, because you immediately see, even if you don't have a test case that triggers an error, when you trigger an error in the proof, you know something is wrong. So part of the problem maybe, and this is a counterpoint to Albert, it doesn't mean that Albert's and Daniel's points are not valid, but maybe part of the complexity is that you're trying to do proof logging as an add-on to a piece of code that wasn't at all written with proof logging in mind, and also maybe then wasn't written in sort of a pseudo-Boolean mindset.
And that is actually what we see as well when adding proof logging to MaxNet solvers. Namely, so you want to add proof logging and you know exactly what to write to the proof, but then you need to find the little bits. You need to find, okay, which constraint are you actually reasoning about? Where do we find that part of the memory that we need? Do we have already bookkeeping to have certain things that we need to write down? And that's often the hardest part, not really coming up with the proof that you want to write down, if you know the proof system well, but mostly the bookkeeping, making it efficient, not taking too much bookkeeping in your solver, but have enough that you have all the information ready to print it out easily. And I think that is indeed what happens if you add proof logging immediately, then, well, you have everything at hand to, well, not have to search in the data structures of the solver that already existed and have been optimized, but you can design your data structures in a way that you can easily make sure that you have all the information ready whenever you're writing the proof. And I think most of the time in developing proof logging goes into this design of bookkeeping, that something's not available in the place where you want to actually print it. And yeah.
No, but I completely agree. So as I told you, Sat4j is 20 years old. I mean, there was it was not designed. There was no proof logging at that time. But for the other proof logging, it was quite straightforward to add it. And in this case, it's complicated. So I agree. So, and actually, really, Jakob, I think that if there is a real let's say, theoretical point against any improvement in that, we can discuss about that, because I think it's just that we need to find, you know, a way to, maybe there are some kind of constraints that can be more or less efficiently be logged, and that would simplify the point. But it's really a matter of what do you want to do? Do you want to exactly register what's happening in the solver, or do you sort of trust the solver as long as what you derived is correct? And this is a completely different mindset.
Yes, I could maybe add one thing more also. I agree, like we want to make it useful. You're absolutely right that you can have different, I mean, the difference between DRAT and LRAT is DRAT, you just say, I learned this, you figure out how. In LRAT, you actually say, this is the conflict analysis. And this is a trade-off between just knowing and knowing exactly how. But it's also a different, it's a trade-off between solving speed and verification speed. Because if you use this LRAT, then you can actually get down to verifications times that are, you know, comparable to the solving time. So it, and for us, like proof verification time is in fact also a bottleneck. Like, so it's a trade, like if I'm making the solver life maybe 5% more complicated, is it worth it if I can cut down verification time from 10 hours to 1 hour? That's another trade-off. I mean, if you put more on the checker, checking will be slow, and that is already a major concern in our MaxSat papers, that we don't have the performance we want, and I think that the end users want. They will, because you also want fast verification. One thing that I want to stress that we're in no way claiming that the current VeriPB format is the be all and end all. One thing, there's very interesting proof logging work going on in the SMT community with CVC5, for instance, and there they have this notion of, maybe somewhat related to what you're talking about, there are proof sketches at several different levels of granularity. Okay? And then there will be trimming in between these levels. So the first SMT proof basically just says, oh, I did this, then I did this, then I did this, and then I did this. Okay. And then first part of trimming will say, well, half of these things I don't need anyway, so don't worry. Okay. However, these things I think I will need. So could you please elaborate a little bit when you said I learned this, like how, please? And then like there will be a slightly finer detailed proof sketch which says, okay, let me elaborate. I sort of, in order to get this, I use these 3 lemmas. Here I had 5 very helpful lemmas. And if you trust me on these lemmas, you should see now how I did this. Okay. And then again, the proof checker might go and say, yeah, thanks. And then it figures out that some of these things, but never mind, it wasn't needed. And this lemma I knew anyway, don't worry about this. So then you have another round of trimming. But then sooner or later, you'll get down to a proof where like, okay, now I really, for these things, sorry, you really need to tell me the details, how this worked. And for some of these things, if you can do it with RUP, then great. And I think most of it will, well, in SMT, it will be RUP or it will be a theory solver thing. What I try to convey to you at a high level is that when you're doing pseudo-Boolean solving, ultimately, some of your deductions will be that you had some kind of polytope and you did a non-trivial number of, you generated a non-trivial number of cuts and you tightened your polytope and then you said, oh, I see that this follows. And then it's just inherent that if what your solver is doing is first it tightens a polytope significantly and then it says, well, given this tightened polytope, here's an easy consequence. Then in order for me to see that this is an easy consequence, I need some fairly detailed hints of how you did your, how you strengthened your polytope. In general, I'm not able to guess that. And it's also like, I could maybe have a proof system that somehow opportunistically says, try to figure it out. But that's sort of, I mean, an important part of the proof logging philosophy is that the reason we trust proof logging is that it's brain dead, right? You're not thinking any longer. You're just mechanically like verifying steps. Someone tells you, I did this, I did this, I did this, and then you just do the calculations and say yes. And RUP fits this because it's like, you know, just doing unit propagation, that's not a huge amount of intelligence. But unfortunately, when you have 0-1 integer linear programs, like one simple thing is like if you get the pigeonhole principle written in CNF form, then we know that that is a polytope that contains tons of stuff. However, if you generate a few well-chosen cuts, you will see that the polytope is in fact empty. And now how can I guess this? Like looking at the CNF representation of the pigeonhole principle, how would I be able to guess that the polytope is empty if appropriately tightened? This is the theoretical challenge.
Good. Then I think we can conclude here. Thank you again, Daniel, for your presentation. And I will stop the recording.